This is Frontline on Air. Major stories on the go.
Shooting for the stars with feet of clay. ISRO's brilliant minds propelled India to space greatness. Yet, the Modi government lacks a clear policy for the space sector. R. Ramachandran.
Writing about India in a recent article in the journal The Space Review, the space researcher Daniel Duchesne of the Center for Space Governance, US, said, quote, "With the successful landing of Chandrayaan-3, India cements its status as the fifth ever great space power. This seismic shift will disrupt the very foundation of the global space order." Unquote. How this observation bears out in the near future, however, will depend greatly on how ISRO makes efficient use of the nation's resources, both public and private, and its own space assets built over the past 5 decades of its existence, and the kind of policies the government puts in place. Duchesne based his conclusion on a ranking that he has evolved called the Space Power Index, which is a quantitative measure of a country's prowess in space. When a state crosses 5% of the total share of space power, it is considered a great power. He gives the attribute space power to a country on the basis of cumulative payloads launched and scientific and military capabilities. Duchesne wrote, quote, "From 2019, when Chandrayaan-2 was launched, despite its failed lander, the mission is far from a failure, and its lunar orbiter continues to send good data about the moon. India's space power has seen a remarkable surge, attributed to both striking scientific missions and military capability demonstrations that have caught the world's attention." Unquote. In the same year, India demonstrated its anti-satellite ASAT capability and thereby its emergent military capabilities in space. By 2022, India held 4.3% of the share of space power, placing it just outside the great space power system. India's ascent was the successful landing of Chandrayaan-3 in the south polar region of the moon. This achievement not only shows actual space expertise, it also caught the attention of the world and shifted perceptions of India's space power. With the inclusion of Chandrayaan-3 as a scientific achievement, India officially crossed the 5% threshold to be 6.6% of the share of space power, he said. However, as Duchesne noted, India does not launch many objects into space. It has launched only 133 objects as of 2022, which is far fewer than the other great space powers in Duchesne's ranking, namely the US, Russia, and China. India had only 4 orbital launches in 2022 compared with the US's 74, China's 62, Russia's 21, New Zealand's 8, and the European Space Agency's 5. Indeed, in 2023, despite big milestone achievements, including the solar mission Aditya L1 that was launched within 10 days of Chandrayaan-3's successful lunar landing on August 23rd, ISRO recorded only 7 launches. Indian Space Policy. One of the key expectations of the Indian space policy, announced in May 2023, ISP 2023, which was another major development in 2023 in the space sector, is that the provision of an appropriate ecosystem for heightened private sector participation, which unfortunately seems to be its raison d'etre, will result in a greater number of orbital launches and space objects launched. We will return to that after discussing the successful Chandrayaan-3 moon mission and the exciting solar probe Aditya L1 mission. Chandrayaan-3 was a forced follow-up mission after Chandrayaan-2, launched on July 22, 2019, with nearly the same objectives, failed in its mission when its lander, Vikram, crashed on the moon on September 6, 2019, while attempting to land. A software error resulting in loss of communication was the cause of the crash. The mission's payload, however, had also included an orbiter, which continues to send data. Chandrayaan 3 was launched on July 14, 2023, with the lander module, also named Vikram, achieving an incident-free soft touchdown near the lunar South Pole region on August 23rd. Chandrayaan 3's success is a landmark achievement not only in the history of ISRO, but in the history of missions to the moon internationally. It is remarkable on two counts. One, while India may be only the fourth country to land successfully on the moon, it is the first to land near the lunar South Polar region at about 70-degree latitude, roughly 600 kilometers from the lunar South Pole. Two, with the slew of instruments on board the lander rover module, Chandrayaan 3 has sent valuable data on the concentration of several minerals, sulfur in particular, in the far side of the moon, which seem to differ significantly from what planetary scientists know so far from studies on the near side of the moon. There are other important findings as well. Of late, there has been a race among the spacefaring nations to land spacecraft in the lunar South Pole region. Indeed, on August 20th, just 3 days after Chandrayaan 3's lander module landed there, Russia's Luna 25 mission crashed in its attempt to land near the South Pole. This was Russia's first attempt since its last trip to the moon in 1976. NASA, as part of its Artemis program, is aiming for a South Pole landing of its crewed mission in late 2024. Why this interest in the rocky and crater and trench-ridden South Pole? It is of particular interest for scientific exploration. At the South Pole, the sun hovers below or just above the horizon, creating temperatures upwards of 55 degrees Celsius during the sunlit periods. Indeed, Vikram's onboard CHASTE, Chandra's Surface Thermophysical Experiment instrument, measured surface temperatures of over 60 degrees Celsius. But even during these illuminated periods, mountainous terrain in the region cast dark shadows, rendering deep craters perpetually dark. Some of these craters have permanently dark regions that perhaps have not been visited by sunlight for billions of years and where temperatures can be below minus 200 degrees Celsius. Previous lunar missions, including Chandrayaan 1, mostly to the visible near side of the moon, have revealed that it is not a dormant, bone-dry planetary system. But these permanently shadowed regions of the moon will contain information of a different order altogether. They act as traps for an array of volatile substances, including water. Studies have shown large amounts of ice there. The ice could contain volatile solid-state compounds that could provide insights into the history of the moon, Earth, and solar system. Ice could be a source of life-sustaining drinking water and oxygen for future manned missions and outposts, as well as of hydrogen for fuel for propulsion and other uses. At the National Space Council meeting on March 26, 2019, the then US Vice President Mike Pence directed NASA to return to the moon by 2024 because the, quote, lunar South Pole holds great scientific, economic, and strategic value. We will mine oxygen from lunar rocks and use nuclear power to extract water from the permanently shadowed craters of the South Pole. Unquote. This puts the significance of Chandrayaan 3's success in the proper scientific and strategic perspective. On August 24th, the day after Vikram's touchdown, the lunar rover named Pragyan was deployed. It ramped down from the lander and traveled a distance of about 100 meters, making measurements to derive the elemental composition in the vicinity of the landing site with its onboard instruments, the Alpha Particle X-ray Spectrometer, APXS, and the Laser-Induced Breakdown Spectroscope, LIBS or LIBS. LIBS made the first ever in situ measurements on the elemental composition of the lunar surface, which, on August 28th, unambiguously confirmed the presence of sulfur in the region, something that was not possible for the instruments on board the orbiters. preliminary analyses of the spectral emissions from the material of the lunar regolith using LIBS revealed the presence of aluminium, sulfur, calcium, iron, chromium, and titanium on the lunar surface. Further measurements revealed the presence of manganese, silicon, and oxygen. Investigations regarding the presence of hydrogen are underway, according to the ISRO website. While the relative abundance of minerals other than sulfur was generally as expected, the greater than anticipated abundance of sulfur came as a surprise and is being seen as a significant finding of Chandrayaan-3. This, according to scientists, provides an important insight into the mineral composition and evolution of the Moon. 2 days later, APXS confirmed the presence of sulfur and the other expected minor elements such as aluminium, silicon, calcium, and iron. On September 4th, after 14 Earth days, equivalent to 1 lunar day of data gathering, with the fall of the lunar night and with no solar irradiance to power their batteries, both Vikram and Pragyan were put on sleep mode. The hope was that they could wake up with the lunar dawn on September 22nd and continue their observations. Unfortunately, there was little residual power in the batteries for the sun to be able to kickstart the Lander rover spacecraft module. But if they had woken up, the additional data they would have been able to collect would have only been a bonus. The tasks planned with the 2 probes as per the mission design were achieved and have already provided planetary scientists with enough surprises to mull over. In just under 14 Earth days, Chandrayaan-3 has provided scientists with valuable new data and further inspiration to explore the Moon, wrote the planetary scientist Jeffrey Gillis Davis of Washington University in St. Louis in the online magazine The Conversation, after Vikram went into its sleep mode. There are, noted Gillis Davis, 2 main rock types on the Moon's surface: dark volcanic rock and brighter highland rock. According to him, laboratory studies on soil and rock compositions on Earth have found that materials from dark volcanic plains tend to have more sulfur, which mainly comes from volcanic activity, than the brighter highlands material. He said, quote, "Rocks deep in the Moon contain sulfur, and when these rocks melt, the sulfur becomes part of the magma. When the melted rock nears the surface, most of the sulfur in the magma becomes a gas that is released along with water vapor and carbon dioxide. Some of the sulfur does stay in the magma and is retained within the rock after it cools. This process explains why sulfur is primarily associated with the Moon's dark volcanic rocks." Unquote. So, one does not usually expect a high concentration of sulfur in the highland soil. Chandrayaan-3's measurement of sulfur in polar regolith is the first ever finding that suggests that the Moon's highland soils near the poles might have a higher sulfur concentration than the highland soils from the equator, and possibly even higher than the dark volcanic soils, Gillis Davis observed. These initial results give planetary scientists like me who study the Moon new insights into how it works as a geologic system. But we'll still have to wait and see if the fully calibrated data from the Chandrayaan-3 team confirms an elevated sulfur concentration, he said. According to him, this compositional difference between polar and equatorial soils likely comes from the different environmental conditions between the 2 regions. The poles get less direct sunlight and thereby attain very low temperatures, which could result in atmospheric sulfur being frozen in the regolith. Clearly, Chandrayaan-3's finding has opened a new avenue of research in the study of the geology of the Moon and its evolution. Before the Vikram-Pragyan duo retired, ISRO carried out a hop experiment with the lander. In this test, the lander jumps from its landing site and moves a little sideways and soft lands again. A helicopter-like controlled vertical takeoff and vertical landing, VTVL. On command, it fired the engines, elevated itself by about 40 centimeters as expected, and landed safely 30 to 40 centimeters away. The test was a demonstration of ISRO's capability in achieving VTVL maneuvers through remote command and control. This kickstart enthuses future sample return and human missions, ISRO remarked on X, formerly Twitter. Coronal heating is one of the major problems in solar physics. The sun's corona lies above the chromosphere and extends millions of kilometers into outer space. Spectroscopic measurements indicate strong ionization in the corona and a plasma temperature of about 2 million degrees Celsius, much hotter than the lower atmosphere close to the surface of the sun, the photosphere, which is only about 6,000 degrees Celsius. This leads to the question of how the almost 300 times hotter coronal temperature can be maintained by thermal processes in apparent violation of the second law of thermodynamics, according to which heat cannot be transported from a lower temperature region to a higher temperature region. It would seem that the energy is transported up into the corona and then converted into heat by non-thermal processes. Aditya L1 will address this problem by obtaining near-simultaneous images of the different layers of the sun's atmosphere to study the ways in which energy is channeled and transferred from one layer to another. The mission, with its payload comprising a suite of 7 instruments, 4 for remote sensing of the sun and 3 for in situ observations, is aimed at understanding some of the unsolved problems in solar physics and heliophysics, that is, the science of the sun-solar system connections. In particular, how the sun's radiation affects the dynamics of the Earth's atmosphere on a shorter and a longer timescale. Thus, Aditya L1 will be a comprehensive solar and space environment observatory located around the Lagrange point L1 in a halo orbit to provide information about coronal heating, coronal mass ejection, pre-flare and flare activities and their characteristics, dynamics of space weather, propagation of particles and fields in the interplanetary medium, and so on. Lagrange points are positions in space where objects located there tend to stay put. At these, the gravitational pull of 2 large masses precisely equals the centripetal force required for a small object, such as a spacecraft, to move with them. There are 5 of them for the Sun-Earth system. These points in space can be used by space observatories to reduce the fuel consumption needed to remain in position. L1 is located on the straight line joining the Sun and the Earth at a distance of 1.5 million kilometers from the Earth, about 4 times the Earth-Moon distance. A halo orbit is a periodic 3D orbit around a Lagrange point and involves an out-of-plane motion component relative to the primary bodies. The orbit is large enough in size to be continuously viewed from the Earth and would appear as a halo around the Lagrange point. From the vantage position around L1, Aditya can view the Sun continuously without the interference of any occultation or eclipse. After its launch, Aditya L1 underwent 4 Earth-bound maneuvers, and from its final 256 km by 121,973 km orbit around the Earth, its trajectory was directed towards L1 on September 18th, at which point its instruments began to collect data. It will reach its destination on January 7th, 2024, about 127 days from its launch date. On September 30th, the spacecraft escaped the sphere of Earth's influence. 5 instruments have already been made operational. The payload Helios captured a high-energy X-ray glimpse of a solar flare on November 7th and caught full-disk images of the Sun in ultraviolet wavelengths on December 8th. So, exciting moments lie ahead for solar astrophysicists. The achievements of the above missions are clearly advanced enough in their scientific and technical scope to attract Duchesne's epithet of a great space power. However, Duchesne also noted that there was no guarantee that India would continue to grow as a space power to match the US, Russia, or China. He observed that Europe and Japan never crossed 10% of the global share of space power, but there was potential for India to grow by increasing the number of space objects launched, which he believed the recently declared ISP 2023 would enable if properly implemented. Currently, India's share of the global space market of over $360 billion is about 2%. However, strategic foresight on the part of the government and the other necessary domestic policy measures, particularly regulatory, are found wanting in ISP 2023. India already has two standalone policies for the space sector. The SATCOM policy of 1997, which deals with different aspects of satellite communication, and the remote sensing data policy of 2011. The science writer and policy analyst D. Raghunandan wrote this about ISP 2023 in the online news portal NewsClick. Quote, "This is the latest in a long series of similar attempts which predictably failed due to faulty assumptions about national priorities in the space sector, the interests and capabilities of the private sector in India, and the interests and motivations of foreign entities to invest in the Indian space sector." The current ISP 2023 suffers from a repetition of all these weaknesses and a failure to learn from past mistakes. It compounds past misjudgments by adding several new and serious infractions of both Indian and international legal frameworks. Unquote. ISP 2023 also seems to be a standalone policy and not a comprehensive space policy that includes security issues and civil-military linkages. It seems to be mainly aimed at throwing open the doors of the entire space sector, barring the areas of security and the military, to the private sector, called non-governmental entities, NGEs, in the policy. It also seeks to provide NGEs with a laissez-faire environment in which to operate in the space sector, with no hint of any regulatory framework. While ISRO has been engaged with the private sector since its inception, over 500 NGEs are currently participating in ISRO's various programs, this has mainly been in the nature of vendors of both hardware and software, or subcontractors and manufacturers of parts and subsystems for different missions. ISP 2023 seeks to turn the present supply-driven ecosystem into a demand-driven one. The elephant in the room is the complete absence of a legislative framework and not even a hint of introducing suitable legislation as was envisaged in 2019 to 21, wrote Raghunandan. At an even more serious level, space law experts have pointed out inconsistencies between ISP 2023 and international space treaties. While the collective brainpower of ISRO scientists has brought about a phase change in India's status as a space power, the actions of the executive and legislative arms of the government suggest a lack of application of mind with regard to putting in place policy measures for the space sector.
This is Frontline on Air. Major stories on the go.